be your host as always. Big thanks to OpenSSF for hosting this live stream about the Salsa project. It's one of those more familiar and yet very intriguing projects that is owned by the OpenSSF. I was first introduced to this project of the OpenSSF before I dove in and did a bunch of like SigStore and SBOM and all of these related stuff. And so it remains a very dear project to me. And I'm really excited about today's demo. There's a fair bit of theory, but there's also looking at a lot of the salsa stuff in practice that I'm very excited about. Our guest today is Teja. Teja works at Harness. Hello, Teja. Welcome to the stream.
Hi Ram, thanks for having me.
It's an absolute pleasure. So, Teja and I met at a very random event in Bangalore where I happened to mention some stuff about open source and security, and it was very kind of him to volunteer and showcase some of the stuff that he's learned about Salsa and supply chain security along the way. Teja, why don't you quickly introduce yourself?
Yeah. Uh, First of all, yep. Thanks for having me, Ram, again. So that was a good time. That was also the first time I met you at the meetup. I'm glad we met, and I'm glad that this came out as a process of talking about salsa here. So I'm Teja. I work as a developer relations engineer at Harness. So I started off getting into all of this into the supply chain security when I joined Harness and getting in detail about it and quite fascinated about how these things are happening in specific to supply chain. When I got to know about it, blew my mind, especially the supply chain attacks with where the attackers are finding different ways of attacking the software, if not direct, the indirect approach. So yeah, I'm getting into this. So all into advocacy relations and DevRel part. So that's pretty much about it.
For some of us who don't know what harness is, what is harness? What do you exactly? What does harness do, and what do you do there?
Yeah. So as I said, I work as a developer relations engineer. But Harness is a software delivery platform, but it does a lot more than specific to software delivery as what it calls as. But it's where it includes the whole CI process and CD, and it also brings up the shift left approach of having security into your pipelines, and as well as you have multiple approaches of developer experience having IDP and some other all these. So all of these are into modules in Harness. So if you want to do continuous integration, you can use Harness CI. If you want to do deployments and you have your own patterns of doing it, you go for Harness continuous delivery. And you have security modules as where you want to bring security into your pipelines and the whole process of your your deployment pipelines, where you want to introduce security. Then you have STO as a module where you want to have scanners, security scanners, and all the remediations and all of that. But the other thing, the most interesting part, and also more relevant for us, is the supply chain security module as a part of Harness, where it aims to bring and ensure that the whole supply chain is secured. Where Harness is pretty much positioning and being there as a supply chain security provider, helping all the helping to secure the whole process of software delivery. Yeah, and I work as a developer relations engineer there, and I take care about enabling the product, especially into supply chain and so the supply chain security module. So I take care about enabling the features and the process of how you implement using Harness platform.
Fantastic. And so, how did you chance upon this whole concept of software supply chain and salsa and things like that? What was your introduction to it?
I got introduced to supply chain. Uh, it's by a security attack with obviously the Log4j movement. I got into I got to know that these are a lot more a lot more complex than I thought, than over a security generic and a direct security attacks. So when there was a Log4j, then I got into understand what the supply chain attacks are. And with the supply chain attacks, I got into understand the software supply chain as a whole thing. So that's where it began. And then I had it as a whole knowledge by then. But then now, as I joined Harness, where there is a dedicated work and a product and all the features ensuring software supply chain security, then I got into more deep and to understand various aspects of supply chain, and also how we secure it in various parts of the supply chain. So that was my initial introduction to supply chain, and also getting into security and all of this.
So, like a lot of the people that I've met recently who've chanced upon software supply chain security, I think Log4j really did us a bit of a good thing.
Yeah.
But I am very intrigued to listen to your story. I know you have some slides and things prepared for us. So, why don't you take us along your journey?
Absolutely. So, as you all know, we are going to focus today specifically on Salsa, a security paradigm for your bills. That's a good title, and thanks, Ram, for that. So, it's a good start for us to understand getting into Salsa and how it can enhance and help us secure our supply chains moving ahead. But yeah, so today what we'll look in is a quick introduction to supply chain and supply chain attacks. But you would be probably knowing what those attacks are like, as you know, as you heard, Log4j. And I hope if you are fully familiar with it, I request you to hold on as we get into the third part. That's where we talk about Salsa. Then we get into the build level specifically of the Salsa version, and then a specific checklist that we have to get into the different levels of it. Out of that, we will need to understand these concepts of provenance and the attestation process, and a lot more as we get into it. So then we could also get into the demo part on looking out how we can get all the levels. When I say all, they are growing, so I'll just constrain myself to talk L1, L2, and L3 of the build level in Salsa, using Harness module, and how Harness integrated Salsa into itself to enable to ensure this build process is secure and also verifiable moving forward into the supply chain process. So, as I said, we'll start with what supply chain in a broad term is. As it calls out, it's a sum total of all the code, system, and the process in a very broad way. But it's the whole point of having everything included, from the part of developing to deploying. So everything as the easiest and the more quickest way to relate here. The simplest way that I could relate is where you can relate to a real-time supply chain, or in an e-commerce specific supply chain that we usually hear, where we have the products produced at some point, and the consumers are at a very different point. And by the time the products reach to the consumer, there are a lot of hands involved in the whole process. And in that process, there could be varying the number of hands that includes, can be much different, and we can't even imagine the number of hands that comes in between. Depends on the demand and the product and all of that. But the important factor that we need to look in is where at each point, or at each hand, there is a high chance of security, there is a high chance of those products getting compromised, or even you get the quality bad, or they steal it, the the attacks specific to theft, and many other things, right? When the product is not in your hands and going to different hands, there is a chance that the products might lose the quality or information. Again, I'm getting back to the real supply chain, but it's more about you lose the quality or you get it theft, and there's a lot happens in the whole supply chain, as we probably aware of. And that applies same to a software supply chain, specifically into your organizations or your whole software delivery process, where you have your code repositories holding your code, and that also is a part of your whole supply chain. And you know what, even before that, where you are starting to build your code, or even write your code, it includes an IDE where you start writing your code, and that is also part of the whole supply chain. So it starts from the very beginning and gets into each part where you code, and then you build it, and then you put it into a registry, and then from there, you deploy it. So, and in between, you might also want to have some sort of security scanners, some feature flags, and many other things that comes in between. So each of these hands, where there is a good chance that they can have an impact on your whole software by itself. So this is a sum total of what I'm referring here, or in general referred as software supply chain. So then, what is a supply chain attack here? So specifically into this whole supply chain that we are talking about, when you look at the supply chain as a whole thing, there are trusted vendors, as we call them, as the source code repositories here, or the artifacts, or sorry, artifact registries. And then when they get into, they could able to compromise one of these hands, they have access to a much more larger network that they can access and even exploit further. So some simple examples to relate here, where you compromise the build process once, wherein our whole software delivery process, you have the build process to build your code and have it. If the build process or the build providers or the services that you're using have an issue with it, there is a good chance, or it got compromised, where your build can carry some malicious code that can eventually compromise the whole system where it gets deployed. So this is one scenario where you have the issue of compromising the build process, which overall affects the integrity of the application, and it can cause in various levels as well. And how that happens and where it goes, it's all depends upon the style of attack, where attackers knowledge comes in, and their whole skill sets. The attackers spending years and years of time doing into multiple aspects and trying out to uh, perform this or compromise the build process as one aspect. And there is another way of looking at it, is where inside your application, where you have your old dependencies, which you call it as the direct dependencies that you wanted to use it. And then those dependencies are also dependent on some other libraries, which we call as indirect dependencies or the transitive dependencies, where and those transitive or indirect dependencies are also dependent on some other libraries, right? So all this dependency graph, or the tree that you have here, at some point or the other, in which level or it is, there is a dependency which got compromised by an attacker who targeted and specifically planned it, and did attack and compromise that library. Eventually that can lead to compromise the software that you have it as a indirect dependency or a transitive one, right? So this itself is a supply chain by itself, and that is connected to one other, and where compromising one affects to the whole, uh, and affects your whole software by itself. So these are the two scenarios I just wanted to put here, but there could be many other ways that a supply chain attack can happen. So specifically about compromising the build process is what we'll be dwelling in a little, so where how salsa can also help us to stand against and protect ourselves to not to let this happen. So uh, getting on specific to the supply chain attack itself, maybe I could talk a little detail, not much time here, but as I said, in each of these points, the producer, source, and build, and all of this process, the whole alphabets that you see there, A, B, C, D, and all of that, each of these are actually an entry point for the attack to happen. So, as you call the ABC or source threads, build threads, and the dependency threads here. So, each of these paths, for example, if you see A, there you say that submit unauthorized changes, which starts from here and that can be carried to the whole process, right? So, at each of these points, there is a high chance of your software getting compromised, and the threats are always there at every point. So the whole attempt of securing your supply chain is where you wanted to ensure that every point of your whole software delivery can be in any means, or if not salsa or in any other ways. It's all about how do you make sure at every entry point, it can be a number of entry points, and you make sure that you secure and make it in any approaches that you choose, you ensure that there is security and the integrity is not compromised. So this is the whole point of talking here in specific to supply chain attack and what supply chains in overall view. And now let's get into the the major supply chain attacks to usually relate with. So this is something I got introduced to supply chains as I was talking initially. So these are some of the major and well-known supply chain attacks that you can. I don't want to get into details of each of this. And if you look at, I really got amazed the way how attackers uh, spend their time and knowledge to get this happen. And each of these attacks has their own approach, and there are any number of entry points and how they can leverage it, and they did it.
Right.
Yeah.
Yeah, yeah, go on. Sorry.
Yeah, yeah, Ram, no worries. So yeah, feel free to interrupt anytime, or any questions maybe I could look out. So then, at each of these points, yes, so I would request you actually get into these stories of SolarWinds, Code Cow, Log4j. The most popular one, at least I am familiar with Log4j at the time I got introduced to it. But yes, all of these are pretty popular, and these are also categorized specific to the compromised CI/CD tools, where the SolarWinds and Code Cow are the attacks that where the CI/CD tools are compromised. And when you look at Log4j or exeutils, but this is the most recent one where there is a compromise on the OSS dependencies as well. So this is some of the examples of two approaches where we are talking about compromising the build and compromise OSS dependencies, or the third party dependencies that you have as a part of your software. So yeah, take a look at these things and you would be able to understand the approach attackers is taking to get control over the software. So next, specific to some metrics here, where 80% of code bases having vulnerabilities introduced through use of open source components itself, and making sure we have the security aspect of open source is also pretty important. And there, the 45% of organizations will have experienced a software supply chain attack by 2025. So this is said by Gartner. And yes, so we are seeing it happening, but probably we'll see where it goes by 2025. But it's important for us to be more secure at this point, and also leverage some of these tools such as Salsa and implement within ourselves to be more, to stand against least, right? So getting on to the specific aspect of Salsa here, what it says by itself is a supply chain levels for software artifacts. So um the first time I heard about Salsa, I thought it's like some sort of a software or some sort of different CLIs or all of that. But what I learned, and I got to understand that it's a pretty standard framework, a security framework specifically, that helps you to ensure the integrity of your software artifacts. So it's actually an open SSS project by itself, the place where we are talking. So Salsa is a project by themselves, and it's these the origins of this Salsa is actually from Google, and then they got into OpenSSF, and then uh, this is a framework that gives a criteria around the software supply chain integrity overall. So it helps the whole industry, the open source ecosystem, to secure the software development life cycles. And now, as we get into the details, we'll get to understand how this framework and what aspects of this framework will help us to be more uh, secure and resilient. So in a quick glimpse around what Salsa provides. So and a unified terminology for discussing the software supply chain security. So I'm just going through a little bit theory here, saying about what it provides, and then a framework to gauge your software compliance with security standards, and then you have a method to assess the reliability of your artifacts that you utilize, and then you have a pretty good guidelines to enhance the security of your own software. Next, this is where you talk about the producer and the consumer part. So when you are a software producer, and having Salsa into your systems is such an important thing that it will allow your consumers to trust upon you, if you and they could also verify some of the aspects along with the software that you provide. In case of SBOMs, there was a part where you do some SBOM attestation, and then you also pass it on and see the verification can be happen, and the SBOMs can be carried forward to the customers who or the consumers, where this the Salsa is pretty much important and more important for producers, and the consumers can also have um, a trust kind of a reliability on the software that they're consuming. So yeah, specific to getting on to the checklist of Salsa, where we talk about Salsa in tracks, where it has source track, build track, and dependency track in the different version. Now in the version, we got only a build track, where the build track has comprised into three levels: L1, L2, and L3, for specific to build. And there could be a chance Salsa would come up with a source track in the future. For now, we have build L1 and L2 and L3. So what we're talking here when you say build L1 and L2 is all of that. Uh, you wanted to comply with some of these guidelines, or maybe you can rules, or anything that you wanted to call. But when you comply with some of these standards that they are provided, you are compliant to the build L1 category, or the build L1 stage probably. So, how does it look when what does it mean when you are say I'm a salsa build L1 compliant? It means that the software producer follows a consistent build process, which can also be reproducible. The process should be consistent as a process, as you build the artifacts out, and the build system automatically generates the provenance. So provenance is a document that should be generated as a part of your build process, which will quickly get into right after this slide on understand what a provenance is. But yeah, as a part of your whole process, the build system should automatically generate the provenance, and this is a requirement. Next, you have a distribute provenance data to customers as a point where you wanted to where you should be able to distribute the provenance that is generated as a part of your build system to your customers. So these three things will make you a salsa L1 compliant. So next, as you go on this, the levels that you see for the next level as L2, this includes L1 as a requirement, where once you are compliant to L1, and then and then that is the first point, first level that you want, that before going for the other aspects of L2. So I'm L1 compliant, and then the next important aspect is using a host build service than local machines or any other local platforms to build your code. So it's important that you use a host build service, which is usually the case in most of the organizations or the use cases. The builds that happen in cloud. And then next you have the provenance, which was part of L1, now should be signed, which means that it should, it should be tamper proof. So the signing process brings a trustworthiness into the provenance, because provenance is a document by itself which logs and covers the whole information of the build process, and what involved, what parameters had come in, and all that as a part of it. So we'll look at a little bit about provenance in the next slide. There, next you come to the part of verifying the provenance authenticity. So that's where the signing and also the data validation as a part comes in. So these are the major aspects of L2 along with L1, and similarly with L3. That is where you also need to be compliant with L2 as a first point, and next you get into the other aspects where you want to prevent runs from influencing one another, where you wanted to have your builds in isolated environment, and not influencing one build to the another, so that you have all this isolated and what we call as hardened builds. So this is the major requirement. And then to give you an overall picture, so this is how it looks. You start with L1, where you wanted to generate the provenance, and then you have the provenance attestation. The generated provenance should be signed, and then to in the L2, along with that, your bills should be running in a host infrastructure, where in case of L3, along all of this L2, you wanted to have your bills hardened and prevent security materials used to sign the provenance being accessible to user defined build steps and all of that. So just giving a whole understanding about the salsa build levels L1, L2, and L3, and I hope you're able to relate here in specific the requirements of each levels and how you can comply it. So it is directly said that if you want to be L3 compliant, you should be first L2 and L1. Yes, so that is how it's said. So pretty much going forward, now the one what we're talking so far, the provenance thing. So this is pretty much a JSON format data, where it's a complete verifiable information about the software artifacts, where it includes the origin and where and when and how they are produced specific to artifacts, right? So uh, this provenance is a complete documentation of this build system. And then why it is needed is there are multiple factors for the requirement of it, where one point, as I pointed out there in the slide, it says provenance can be analyzed and verified for security purposes to ensure that there is no tampering. This is one aspect of it, where now you have these details documented. When you are going for the deployment, to ensure that there is no change in it, you can enforce some policies, or you can enforce some sort of a rules on this provenance, and making sure that the data is matching. For suppose you have a repository that you pulled the source code from, and you built the artifact out of that code repository, and that is the one which is supposed to go for the production. And in your provenance, you will be documenting the GitHub repository, as you can see the repository URL here. So now that you are at the point where you want to go for deployment, you wanted to ensure that the artifact that is going for deployment have this provenance thing, and you wanted to also verify the repository that is involved in this provenance, and it should match with the repository that you expected, not that the intruder came in between and changed the repository URL, and then if there is a mismatch, then you can quickly abort the process of deployment. So this is one of the process where you can leverage provenances to ensure that you are that the deployment is happening to the right artifacts from the right sources, not from the attackers sources or any of the other sites during the supply chain attack process. So yeah, so this provenance is a part of the salsa, and at each stage you have different things. In L1 you wanted to have it as a generation, but in L2 you wanted to have it more secured, where this provenance itself can be compromised by the attacker, where you wanted to avoid it by having a test. So that is one aspect. So we are talking about attestation, but what it actually is where it's a pretty signed document, where we'll look at that, where we'll be generating a .att file, which is an attestation of the provenance, which includes the metadata of the artifact, and that metadata will also includes the original build process and all of that. So we will be looking at the Inteto attestation, the process behind the scenes that happens, where you can actually use the Inteto attestation framework for performing this whole attestation process, to validate the origins and all the other aspects. So you can look into GitHub repository of this Inteto attestation framework, which is quite popular and pretty much used mostly. So I'll be using that, but yeah, but what I'm more excited about is the whole process of how you can become a compliant to L1, L2, and L3 with Salsa. So that's what I wanted to quickly dwell into. So I'll just quickly take some time to walk you through this diagram here. So first is where you see this. This is a simple salsa generation attestation process by itself here, where you're taking as a code repository the first process. So you're building the image. So here this process is more about you generate the provenance and attest it. So for the process that is documented, where it starts from the code repository, so you take it and then you build the image, and then you have the provenance generated, where it need to be configured in your CI systems to have a provenance generated, and then you have this provenance attest, which is generated as a part of it. And then these things right up here till the provenance generation you are L1, and then when you are wanting to go for the attestation, that's where you're stepping into L2 part of the build track. And then you have these hardened builds and host build services. This is also requirement for the L2. And next, if you need to make it hardened, and that's where you become L3, so that these things are isolated and not in contact, or sharing the information one between one another, or among one another. So for the attestation purpose, it requires a private key and a password, and once it has that, so it creates a .att file as a part of it. It varies from one to another, but I'm sticking to how Harness is doing it here. And then here, as a build process, when you are building it, you also want to do this also does a push image. So what Harness here are doing is, you have the build and push step, which takes the image artifact and also the attestation file, and both of these will pushed into the container registry. So you have the attestation in the registry itself, and next you have the container registry here. This the next part is where the salsa verification part. This involves verifying the attestation that you have done with the private key and a password, and next is actually verifying the contents in the provenance, where you wanted to make sure that the data is not changed, or the source or any other aspects of the provenance is not modified by the attackers. So for the purpose of attestation verification, you would need a public key to do it. And next, following it up on, once you are very good and clear with a green sign on attestation verification in the signing levels, next you go for verifying the contents, or where you wanted to check some of the aspects of branch or the repository or who triggered it and all of that, with the policy set. So all of these are included as a part of the harness platform, where you have the private keys and passwords and policy sets and completely involved. So yeah, so this is something we'll look at now quickly on how you can achieve this salsa generation, attestation, and also the verification part. So I'll quickly stop by and see if there are any questions, or I could go for the demo.
Yeah, I think the demo is probably a bit overdue right now, considering
Oh.
that it's been a lot of slides. But um, now I had questions about, now this can be applied irrespective of infrastructure that we have, or what kind of, I guess, prerequisites does it place on certain kinds of hyperscalers or cloud infrastructure and things like that?
So those your software builds, the requirement that Salsa provided is where there is a chance that it's very less, but the builds are happening in the local systems or local VMs and all of that. But the requirement is such, it's important that your builds are happening in host services. So that is the requirement, and then making it hardened is something to the next level of L3. So this is the difference they are bringing in L2 and N3.
Cool. Yeah, let's step into the demo. I'm very eager to see what you've prepared for us.
Okay, so do we have time, or I could just quickly run through the demo, or
Oh
I'll
no,
just.
there's 25, 30 minutes more. So
Awesome. Okay, so yeah, I'll just quickly step into demo, and you look at how it works. So yeah, so what you see on screen is a harness pipeline which I've already created, and here for presenting how it does. So there are two stages. One is part of build, another is deploy here. So in the build stage, you have the whole process running here, where you start with building the code. I'm just running a background service, Docker in Docker, for performing all the security scans and all of that. So it starts with building your code. Even more before it clones your repository first, and even more before it provisions and all of that. But I just get into building code, and you spin up this Docker in Docker and perform all this generic scanning that usually perform. So I'm just bringing out here a much more matured pipeline to make hoping that it aligns with your own pipelines and where you can bring salsa here. We'll look at a much simpler and a shortened version, more focused towards salsa as well. But this is just a walkthrough. So here we have the build and the DIND, and then you have the SAS scanners for performing SAST, and then you have SEA as well, and some you have Git leaks specifically. And next, after that, if you're good with all of these checks and the scans, you go for building and pushing this your image to the Docker registry, and then you wanted to also perform an SEA here. So yeah, this is more specific to SAST, and then here we are doing the SEA right after the container is created. So right after that, we are also doing something called an SBOM orchestration process, where it pulls out all the dependencies and the whole data related to your artifacts, and then store it. So, but where is salsa happening here? So that's where you have this already configured in the pipeline. You, as you can see, as you get into overview, you have this salsa provenance part. So you can quickly enable this. Just enabling it will make you an L1 by itself, because it starts generating the provenance for your build process. And next, while giving the keys here, so as you click on private key and a password, you need to enter your private keys and passwords that you can generate using Cosign. So
I'm
this is.
sorry. Can you spend a couple of minutes just to clarify what cosign is, in case somebody doesn't know?
Oh, okay. So I use it Cosign for generating the keys, but in general, it's a lot more. But I think Ram, you would be the right person who worked with Six Store to talk us about and let us know about what Cosign and Six Store relations.
Yeah, I just wanted to interject. My guess here is you require a private key and
Mm,
the password associated with the private key. The cosign is a service that helps generate a lot of these attestations,
yeah.
and it is a service that allows you to generate these private keys that you can then use to sign your build, to showcase that you're the one that has actually built it. So if you add your private key that was generated using Cosign, it'll have a registry typically. So sig store comes with a bunch of different components, one of which is the signature itself and one of which is a registry for these signatures. So if you want a private key, one of the best ways to do it is to generate it with Cosign, and that's what Teja has done here. Just wanted to clarify it for somebody who
Yeah,
might
yeah,
not
yeah.
be
And
aware.
also the registry is something you are referring to the record.
Yeah, that's right.
Mm. Yeah, pretty much. So yeah, so the way how you also generate these keys is something you can, maybe I can quickly show. So I had this used before, so maybe let me get into some. And so you have this Cosign CLI that you can use to generate these keys, and then also store it inside secrets here, or you can actually give it as inputs. But these are files. I think you need to store them as secrets. So the command that you can use is Cosign generate key pair. So once you have it installed, you can use this command to generate a key pair. And once you ask for it, it will ask you to enter the password for the private key. So if I give something, I've just entered it, and then as you hit enter, it's asking for again to verify, and then yes.
Yeah,
So it's already there, it's saying, so I can just say yes. So here it generates you cosign public and a cosign uh, private key, and then the password is something you have to remember for doing it. Yeah, Ram, you're saying something.
no, I was just going to say it was going to overwrite something because the file probably
Yeah,
already exists on the path.
yeah,
That's all.
yeah, yeah. True, true, true.
This is again one of the best ways to generate keys, one of the more convenient ways right now. There's obviously different ways that you can pursue that are all probably compatible. But yeah, let's get back to the demo flow. Sorry.
Yeah, yeah, clear. I'm glad that you brought this up so that we'll be able to also get in a little more detail. So yeah, this is good. And yeah, so you need to enter your private keys and passwords here. So in Harness, you can do it with something called harness secrets. So this will bring up some sort of secrets that you can create. So when you start creating a secret, you should be able to add these things so that your keys are also encrypted and decrypted when they are utilized. So that is something done with the harness secrets. Once you have it, you can configure it with the private key and password here. And next you get into the major part is about generating this option about generating the provenance, and this is for the authenticity purpose, ensuring that your provenance is signed and trustworthy there. So the other part is where the infrastructure. So this is what we are referring to. I can use my local to perform this build, but if you want to be L2 compliant, it is very much important that you use host services to perform this, and it is something also very important to have this isolated for becoming an L3 compliant. So in my case, I can use a cloud here. So it will it and not it. So cloud does the job for me, and then you get into the execution part. So now, as a part of the whole process, the build and push thing. So this build and push requires the repositories that we have configured and where it is all going, and that all things will be documented. So as a part of the provenance, so we'll look at that in a while. So next in the deploy phase, before I get there, what happens here is in the build stage, as I was talking to you here. So this thing will push the image, and it also generates the attestation. We have given the keys for it, and then it pushes to the container registry. So right after this build process, you can view the attestation file in your container registry. So that is the part that is an important takeaway from this build process. And next, now that you have your attestation of the provenance, it is also important that you verify the authenticity of the provenance that is generated as a part of your build process. So that is where we wanted to do a verification of the provenance in both the levels. One is about the attestation verification, another is about enforcing a policy to ensure that the data is not uh, modified. So as you get into the deploy stage here, that is what I'm trying to do here. So we'll start with the salsa verification, which is nothing but a provenance attestation verification. So here I perform the attestation by referring to my Docker hub and the container registry and the image and all of that, and giving a tag. Next, I am also doing a SBOM policy enforcement. This is more like open source governance, where I strictly wanted to avoid some licenses. I strictly wanted to avoid some sort of versions of a specific dependency to be a part of my process. So I'm just making sure that there is nothing against my security policies specific to our dependencies. So this is something I'm doing it, but it's not needed in our context. So yeah, so after this also verification, the policy enforcement is happening, and then the deployment, the deployment is happening here. So this process, as I was referring, this specific thing, the salsa verification, is where you do two levels: the verification part of the attestation and the policy enforcement. So that requires a policy set to be added. So as I show you here, you have the verification part, and then you have a ISPOM policy enforcement. So here, it just couldn't find the policy set, but yes. So you have yeah, salsa verification policy set here. I can just add it. So yeah, that is what I'll also show you how the policy set looks like. But yeah, so you're ensuring first step is where you're taking a public key for verifying the attestation, and then you're also enforcing a policy so that you check the contents. So yeah, so that's the part of it. And then if you get into the policy under security and governance, you have the policies list here. As you get into the policies, you should be able to find, maybe it's not in project level, so in harness there is org level and all of that. So as I get into organization settings, so you should be able to find some policies here. Then from here you have policies. So yeah, so the salsa verification part, I have one policy here. This is a very shortened to give you a gist about how does it work. So what I'm trying to do here is I'm going to check that the repository URL inside the provenance should be this and nothing anything else, and should not be anything other. So I wanted to make sure the repository URL in the provenance should be this and not anything else. Then also I'm making sure that the data is the repository branch should be main, and you can do a lot more here. I'm just showing you two cases, but you can also do some who triggered by and some of the things that you are inside your provenance that you want to verify. So what I'm using here is um, an OPA based service running here. So I'm using Rego language to write these policies inside harness, and once you have it, you can enforce them on the provenance. So that's the part. And now, so this is pretty much the part about how you enforce it. So now let's get into the details and how that looks like, and also look at how a provenance looks like and all of that. Instead running it, I'm getting into an already ran successful case. So here, these are the two stages. You can ignore this one. The two stages, what we did is build stage and then the deploy stage. And in the build stage, we are generating the provenance, attesting it, and then doing all of that for the authentication purpose. And next, you verify that salsa provenance in the deploy stage. So as you have seen in the build stage, maybe I'll give you a console view. So this brings up a more detailed approach. So here, these are all details related to the scanners. And then here in the build stage, so we are doing provenance step group here for generating the provenance, and then we are performing container scanning here. But yeah, uh, to clearly show you the process, so I'll take to here itself into the, yeah. So as you see that here we are starting out something called provenance step group, and then it started documenting it. So in the build and push step is happening here. So this is the build and the push part. Here in the deploy part, you are doing a verification. So as you can see that we have a salsa verification step which talks about verifying the attestation part, and then you have the policy enforcement, the next step, where you have if there are any violations, you can also configure this to literally block or even stop the pipeline execution if there is any violation based on the policy that you're configuring. So this is the whole process how it's happening to it. But let's get into see the provenance and all these artifacts. So that's where you have this tab called supply chain, and from there you see that you will be able to find the the artifact specific details. You should be able to download SBOMs and all the other details, but what we are more interested in is about the salsa provenance part. You have it generated in the build phase, and now you can download it. So yeah, let's look at how the provenance look like. So uh, I'm not I didn't have a formatter, I guess. Maybe yeah, I did. So yeah, as you can see that repository URL specific, and this is most simplest provenance that you can see here, but probably you will have more complex as you have further details involved. So each of this has its own references, and it's followed by salsa structure that they offered in their docs. So this is something need to be followed, and then each of it includes the run details and some internal parameters and specific details of it. But it can vary as well. So as again it goes to the version of salsa version 1.0 structure of generating a provenance. Here in specific, in the second part where you have a deploy stage, here there is a salsa verification which is saying successful, which means that the attestation was successful and it is not tampered in any means. So that happens through the cosign, again the same part, but using the other key for the verification purpose. So yeah, so this is how you perform all this process of provenance generation and verification as a whole. There is another thing that we also added. Since we added the security test, you can also look at some of the security tests here, which talks about some critical high vulnerable aspects. So yeah, so this is pretty much about it. But I'll stop here before I jump into further parts of doing it lively on a shortened version of it, and see if we can have any questions.
There's one question that's somewhat um, basic. Um, Achanandi asks, how is Salsa different from DevSecOps? Do you want to
Uh,
take that?
yeah, I can add a little bit on it, but you're open to even include more details on it. So DevSecOps essentially about you wanted to bring security into the very essential aspects of this software development. At every stage, you wanted to make sure that you have it all secured, and moving forward, you don't want to come back and say this is not secure now. Now you rework on it, right? So that's where we want the introduction to shift left approach of introducing security at every aspect of the development process to enhance the whole process of delivery without having much security issues. So that's where the DevSecOps whole process comes in. Um, but this is more towards the shift left approach, the DevSecOps point of view. Where it comes to Salsa as a whole, that's where you are ensuring that your whole process is kind of hardened as something like they're all bound having a certain boundaries over making sure the exploits doesn't happen, and all these provenance approaches. It is more towards the supply chain itself, and ensuring you stand against the supply chain attacks before they happen. So these are related to the security of the whole DevSecOps process in one or the other way. But looking at if there is a close attention, I feel these are involved each other, but they are distinctly different as well. So Ram, you would like to add upon that?
Yeah, I think they're not mutually exclusive of each other. So, one of the ways to realize DevSecOps is to make use of some of these tools as a DevOps person. Um, you can start implementing Salsa as part of your larger DevOps
True.
strategy. And so you make that a DevSecOps kind of uh, approach. So it's in the larger scheme of things, the OpenSSF aims to provide a bunch of different projects and steward a bunch of different tools and provide a bunch of different best practices that aid you in the transformation from DevOps to DevSecOps in a way. So if there's security workflows that you want to include, then you can add these. The next question we have is: I have no idea how an attacker can compromise the build process. Can you explain?
Mm. So that's where we would need to get into some of the use cases, what happened, and some of the most prominent attacks. Uh, Essentially, the recent one, executils, where you had they got in. There was some. So one use case, I'm not fully in detail about how it happened for exe, but the overall structure happens in such where what happened there is where you have the maintainer. There was a maintainer who was maintaining the repository, and then uh, they had to get into they involved different aspects of the code where they start adding codes that are malicious, which cannot be quickly identified within a go, but they keep on doing the same things with different files and different structures, making it out a complete plan of attack for performing the for compromising the artifact. So they attacked that specific they added this code which can affect the whole build process by itself. From the repository, from the maintainer itself, it just started. So from there it went upon, and then when it happened, they triggered out, and then there was a news about how they figured it out. And there is another use case where you also look into the recent one. Probably I found it out yesterday. The polyfill library, or the polyfill CDN. When if you have polyfill in your files referring to that CDN, then what's happening, they are redirecting it to a different sites. So without any control over it, if you have it polyfill, then your sites are getting redirected overall, but in any means. But so how this happened is where polyfill, the news is such, there is a Chinese organization which brought the domains, and then they started to or send this out, the different version of it, and then they started using it, and then they got attacked. So it happens in multiple ways as such. And there is also some way of you changing the namespaces. So for suppose you're using uh, what do you some library for performing a request, and for suppose Axios you're using in the npm, and then you started making requests. But if you have your npm getting auto updated, and then there could be some typo squatting, something where the attacker makes a relevant or a similar thing, and then it pulls out a different repository than the actual one. And once you are using the attacker's repository in your code and started using it, it's pretty much you're unknowingly compromised. So there are it's a number of ways and different approaches of attackers coming into the supply chain, and it's also equally challenging to secure at most of the entry points. But so these are some things I've gone through, and also well surprised at all of this. And also the log4j part, where it also has some dependency and compromising them. So, what about Ram? Anything else that you want to touch upon? Some interesting stories here on
Yeah,
specific.
there are a few stories, but if I say them out loud, people will probably become paranoid. But it might scare them too much. But in theory, the way this is supposed to work is when you have public infrastructure for your applications, and then because this public infrastructure runs other workflows and processes side by side on the same host.
Mm,
On one of the instances that I heard about, the host machine that ran both a web application and some builds were compromised because of certain libraries in the web application, by which certain attackers got access to other workflows that were executing on the same host machine on that particular cloud provider. So a lot of different applications which over time used the same infrastructure as this infected application then had all of their code basically injected by the attacker. So it was a very roundabout method to gain access to certain people's applications. But one of the things that happened on this compromised infrastructure was build.
mm,
So when a second party's build was happening on the shared infrastructure, it was then inserted with malicious code because the attacker had access to the host system in entirety. So um, it's a scary world, but um, there's processes and guidelines like salsa to prevent exactly these kind of attacks.
Yeah, totally. So I hope you had some other stories that are not yet out, probably planning some supply chain attacks there.
I really hope not.
All
But
right,
I
okay.
think this
Hmm.
was good. I particularly enjoyed prefacing all of that theory and then showing that in practice. And it's wonderful that a tool can um, cover so many different aspects of supply chain security and things like that. When I started working with open source many years ago, it was a bastion of nothing will affect us because we are open source and things like that. And it was not true then. It certainly isn't true today. But then we're also, as a community, working towards making open source that much more secure and consequently that much more usable and reliable to work with.
Yeah, yeah, definitely. So that's where the OpenSSF I relate to something OpenSSF scorecard specifically. Like the supply chain attacks, one most popular entry point is where you compromise the dependencies, and from there you enter into the software. That's where you want to ensure that your libraries that you're using, the whole dependency list. In many organizations, they have a huge list of it, but not knowing the health of it is something that is pretty crucial. So that's where I feel there are scorecards from OpenSSF that they can go to get to understand the health of those dependencies, and then make a choice on quickly at acting against them.
Yeah, but I mean, one thing I feel bad for is this stream is only one
Yeah.
hour, and definitely all of these topics require a lot more time in terms of coverage and a lot more areas to discuss and provide understanding about. But then again, thank you so much for coming forward, taking the time, and doing this session with us, Teja.
Absolutely. Thank you so much for having me, and thank you so much for listening. And I look forward for anything. Maybe you can find me in LinkedIn. So maybe you can search my name in LinkedIn. I can find it, or maybe if you find a link, you get it. So yeah. So that's pretty much about it. So thank you so much, and good to be here.
Yeah, I'm just going to spend a minute or so with some housekeeping announcements.
Yeah.
So if you can just bear with me. So if you want to check out the Salsa project, please scan this QR code that's visible on your screen. It'll take you to the project page. You can learn a lot more about the project from there. There's a whole bunch of different courses that the OpenSSF produces and hosts as part of Linux Foundation training. If you have any interest in security, you want to learn about security and things like that, please once again scan the QR code that's available. And yeah, those are the general housekeeping announcements I had. Thank you so much for staying on the stream. Thank you, Teja, for all that time. With that, we'll sign